Hello, everybody. Welcome to a new session of the Twitch ERNI Academy uh, community. In this case, we will talk about QA and automation using .NET 6.0. Today, we had a lot of content to cover. So first of all, say that this presentation, this demonstration is performed by ERNI community QA community team, and I expect that you enjoy it. Please feel free to write your comments, questions on the chat, and I will be addressing it as soon as I can. Okay. For this session, I prepared a few slides, very quick, just for make the contextualization about what we will talk or see today. But quickly, we will jump to the Visual Studio code. Not the code, but to the Visual Studio, and we will start to demonstrate the work hands-on on the code to build this automation project from scratch. Let me share a presentation. Okay. Start automation project using .NET 6.0. At ERNI, we had experience working, preparing or building these automation projects from the scratch. Let me present before about me. I am Dídac López. I am principal QA at ERNI, and I enrolled the company like 7 years ago, and I faced really challenge projects regarding automation in complex environments and very tied to the regulation, where the evidence is it's key for the process. Okay, my background in this kind of projects, it's working with .NET technologies and also with Python, but relying on Selenium, Appium, WinAppDriver, and these open source tools and frameworks from the market. Okay, a bit of context about where we are, how we arrive here. We, from different projects, we found problems, real business problems that were the same in these different projects. So we had a lot of effort duplication. We decided to start to building something that could resolve those problems. Also help to include good practice and code guidelines along different projects, facilitating the robust scalability and reusable infrastructure of our solutions, and give more facility to jump from one project to another and add value to them. Also, we are boosting the testing project since we built something generic that is separating the part of the business from the part of robustness of the and scalability, allows people to boost on automation, to start from to start on the process much easy, and provides instead of reinvent the wheel each time, provide us a time to think in what's next, how we can test better. Let me give you this testware overview. At this point, through the chat, we will share a GitHub repository that is the one that contains the code that you will see today, and how we arrive here, or what, why, and how this is helping us. So first of all, this repository that I am talking about, it's an alive repository that contains this abstraction and generalization from real business projects, and also is a repository with a roadmap. We have some features that are not there yet, but we are working on increase and include. And again, it's open source. Everyone is invited to collaborate. It's using the latest technologies. So probably if you work on this world of automation, you see a lot of automation projects that started many years ago and are in net framework 4. Whatever. Here we are working with .NET 6.0. That is the future for the .NET, the long-term support version, and also is using the latest version of Selenium, of Appium, etc. Here on this framework is ready to work with several interfaces like web, mobile, API, and also WPF or WinForm applications. How the framework works, I will show you a bit later, but in a highlights, we are using dependency injection, reflection. It's flexible and configuration tag-based. And again, it's separating the part of the robustness and flexibility for the part the validation and verification. A high overview diagram just to put an image on your mind. We had the part that we call engines. These engines are addressed to connect with these frameworks and tools from the market. One engine could be an engine of Selenium or another an engine of Appium. We are using REST to connect with APIs, wherever we need. It's abstracted as an engine. We had a part of the core that has the capability to pack these engines and inject to the business objects and also to the reusable steps. So we had in gray the part of the business validation, how we represent the business objects, and in the part of the engines we had this part generic reusable that we can use at any project. Another interesting thing for this practice is that we will be using a spec flow to define the test cases. So the test cases are in natural language. I don't know if you're familiar with the spec flow, but this is a BDD framework that allows you to define the test cases in natural language and connect with the reusable steps. So really quick, really short presentation. Let's jump to the code. Okay, this is a download, a clone for the repository that you can find at GitHub. I just downloaded the samples because the idea is that today we will create a new sample project that we will test. We will execute tests on different platforms, on Windows, Appium, and web. In different test cases, but also on the same test case. We will see how the configuration is affecting, how is the flexibility. The idea here is not to talk about test cases or where and how to cover perfectly all the scenarios and so. But to see the flexibility on the configuration and how the same test case could instantiate several drivers and interact with them at the same time. Let me show you a bit of the core. Here we had a project that is the core. This project has no dependencies with the rest. Important things here. The container manager, that is the manager that will allow us to make the dependency injection to resolve the component that we want. An engine manager base, all the engines are engine manager base. Okay, the automation lifecycle base is a class that handles the lifecycle of a test execution. The the before test run, before test feature, before test case, before test steps, and the afters, and automate some interesting features like get automatically an evidence from this. Let's see the interfaces. I think this is the more interesting thing here. We had the iTestWare component. This interface is an empty interface that we will use when we want that a business object is automatically registered on our execution. To do that, we just implement this interface and the framework and the testware, which will detect that this is a business object that is sensible to be injected or resolved. Resolved in this case. The engine manager contains the methods that any engine should implement and are linked with the life cycle of the execution to initialize the driver, to destroy it, or the evidence collection. Okay. Moving to the part of the engines, a bit here, we had those 4 engines: Appium, WinAppDriver for the Windows desktop application, the REST Sharp for APIs. Today, I'm not focusing on it, and the Selenium one. All the drivers has its own manager where it's implementing those interface this interface that I showed you before, and also has the supported the configuration tags that are the tags that this engine recognize. When I put this tag on a test case, this engine will be activated. Okay. This is a high overview of the important parts that we need to know to work with this core. Let's start with the creation from scratch of this automation project. So first of all, I will add a new project. This project is a SpecFlow project. I will call Twitch session. It's located here in the part of the samples. Okay, create. We will use the net 6.0. In this case, we will use the MS test as a test framework. Okay. Now I had my project over here. Okay, so right now I use the plugin of the SpecFlow to create it. It is a SpecFlow project, so it is created with some folder structure, a sample feature, and a sample step definition. We will, I don't know if you are familiar, but we will see later. The part of the driver and the part of the support are folders that we are not using on this structure because the core is providing us this. So I am deleting these folders. Oh, okay. So in this case, if I rebuild the solution, since this sample project contains a feature file with a test example that is these examples about add 2 numbers is detected in the test explorer. Is here ready to be run. Add 2 numbers. This is a simple test case, but we will use it for the scope of this talk. Basically, it's saying given the first number is 50 and the second number is 70. When 2 numbers are added, then the result should be 120. If I try to run this test case right now, we will see this warning symbol that is raised by the step definition that because it's throwing this exception, this pending step exception is for this reason that it's putting the warning symbol. This step definition basically is connecting its method of this class definition with the natural language text that we had on the feature file. Perfect. So let's start to create this automation. Happily, I have a calculator that is the perfect application that I need for automate this test case. Instead of change the test case, I will look for an application that fits it. Okay. So we will make this add operation that we saw on the test case over this Windows desktop application. First step to do that, it's first step to do that, it's adding the configuration to our test project to detect the to detect the proper engine to run this mini classic calculator. So far, I will close it. Let me add the configuration. So I will create a new item. The item that I need, it's a JSON file. The configuration that I will call it configuration. So right now I had here a configuration file. This is not needed for me. Okay, let me, to avoid typos, let me copy and paste a template for the configuration I am explaining. So here we had on the root of the of this JSON, we have configurations where we will put all the configuration of the different drivers that we will need to we will use for this test project, and also the test results path where we want to store it. For the tag, as I mentioned, in this case, we're in the WinAppDriver. Here in the factory, we had the configuration tags. We had the configuration tag for the WinAppDriver. So WinAppDriver, it's our tag here. For the name of this specific capability, because we can have multiple capabilities for a WinAppDriver. For instance, we can open the calculator, but we could be open another application, so we can have the capabilities of the other application and so on. Each capability group, it's identified by this name. So I will put a calculator desktop, for instance. Okay, the path where the calculator is. So I am copy pasting. It's not important. The important is to put the path, but it's not important what is it. The application name. In this case, to find the application name, we need to start to inspect the application itself. To inspect a Windows application, we are using Accessibility Insights. This is an application, an update later, maybe later. These Accessibility Insights help us to identify the properties of a Windows application. If I am moving, I am hovering the application, under test, the Accessibility Insights is detecting the different buttons, as you can see, and it's also giving me some properties that I can use for the automation and other things. So In this case, I had the class name. For instance, the name, it's the name 1 because it's the button 1. The automation ID, that it is similar to the ID on web, or the accessibility ID on Appium. In this case, I need to identify not the title, but yeah, the whole application, that is this dialog, and I will use the name Mini Calculator Classic to identify it. Let me stop the detection. Okay. Why we need to oh, sorry. It's I didn't copy correctly. Why we need to put the application name? Because how the code works, it's attaching to the whole session of the windows and then look for a specific application and reattach them. This solves the problematic that we found at some projects, that the splash screen of the applications was broken the direct instantiation of the driver. Okay, we need also the WinAppDriver URL. This is the URL for the Appium. The WinAppDriver works with Appium. I'm using the default one, so nothing much to say here. And on the part of the test results path, I will wrote this path that is a path that will be able to work. Is this path over here? The folder is empty. You can see it, but we will check later when we had results to see. Okay, we put this new configuration of in our configuration file. So we need to say to tell the test that we will use this specific configuration. In one hand, the configuration of the engine that we want to use, and in the other hand, the specific configuration for this capability. Sorry, it is possible to, well, we had like this. So more things that we need to do before start. I show it to you that we had the Lifecycle Manager. This Lifecycle is is this class that is handling internally some interesting features like get the evidences and so, but has some methods abstract that need to be implemented by the own test project. So let me add new class. I will call Lifecycle. Okay. So this class Lifecycle will implement the will inherit from the automation Lifecycle base. I need to add a reference. No. Okay. For some reason, it's not getting automatically the dependencies. Let me add the project reference to the core, and let me also add some other reference that we will need later just to save time. Okay, using automation test where now is complying because this abstract methods are not implemented here. So let's ask Visual Studio to do it for us. So are those trees. The first one, we need to return the configuration item. We need to, it's requesting for the configuration item. So this is a new, we are using the configuration manager that we had in the core that has this read configuration file method that is capable to read our configuration .json. Okay, yeah, there's a problem. No. A mistake here. Okay, I think I had a typo. Let me check because no, it's not this. Sorry about that. Come on. Configuration file. This method. Yeah. Okay. Okay. Yeah, it's an static method. It's not the new. In this case, the autocomplete of this version of Visual Studio works against me. Okay. Yep. Okay. Perfect. So we had this. One thing that I forget to do is to go to the properties and ask for the configuration file to copy always. Important. Otherwise, it will be not on this path. Okay, the second method that we need to implement is the method to say to the core where is the assembly or the assemblies that contains our testware components. In this case, we will put all on this same project, on this assembly. So the method looks like this. Variable of assembly, call assemblies, equal new. Oh. I get the type of this class, Lifecycle, and I get the assembly. Easy like this. At the end, I return the assemblies, the assemblies variables, and that's it. The last one, that action that I need to do, is to return, to initiate and return the drivers that I will need to use on this project. So far, we are going for WinAppDriver. So I will create this this for the WinAppDriver. Engine manager, engines equal new. New WinAppDriver manager, one reference missing, manager. Let me add it. Okay. Reference engines. Now the autocomplete is working on my direction. Perfect. So we had the life cycle here. We had the configuration. We had the tags. One what we need to do next, this is more attached to how a spec flow works, but we need to use the hook class. We need to include the hook class. Let me add a new item. SpecFlow has, the plugin of SpecFlow has again a plugin, a functionality to automatically create this kind of class. Has the binding that is a tag, a decorator used by SpecFlow to understand that it's something that he should attend. I will delete this example hooks, and at this point I will make a copy of the content of this class, and I will explain it. One nice thing that has this net 6.0 thing is that for the next spaces, it's a nice thing for me. You can put it like this, and you don't need to indent the whole file, the whole classes and so on. But I'm not doing on all the projects because I will lose a lot of time. Okay. First, I had here an object that is a Lifecycle. Is the class that we just did it, and this Lifecycle contains the actions to handle the life cycle of the execution, as I said. So I'm just connecting the SpecFlow, the SpecFlow hooks for the before the run, the before feature, the before scenario, with the life cycle methods. The before the run, I am saying to the life cycle that I am beginning the test execution. I am beginning the test suite, sending the name of the feature file. I am beginning at this case, sending the tags that I had on this specific scenario. I am beginning a step, sending the description, the name of the step, and in the after line, I'm just end the process, the execution events that are happening. Okay, only that, only this. Okay, let's run it again. Let me close the application, and to run this, I need to open Appium. As I said, this WinAppDriver is connected with the Appium application. So I am opening and creating a session to do that. How it works, Appium is considering the Windows processes as an application, similar how the accessibility inside detecting the desktop one with the things inside. But I think I stopped no, I need to hover to update. Okay, perfect. Appium is loading. I think I had a problem with my RAM. It's with the stream and all the things open. It's not going so fast as I like. Okay. I'm default configuration. I'm just starting a session. The direction is the same that I put on the configuration. So let's see what happens if I run. I hope it works. Okay. As you can see, the application has been opened and has been closed at the end. So the life cycle is working. What is not working is the implementation. We are still with the warning symbol because we still has, let me make a cleanup, close all tabs. Here we are still with those steps not implemented. So we need to start with the implementation. To start with the implementation, this time we will use the page object model, the POM, a classic one. So I will create a new folder for this POM inside the same project. This is a decision of the project, of the architecture of the project. If you want to have a project, a different project in the solution for any POM, it doesn't matter. It's okay. The framework, the only thing to need is to pass the assemblies in the lifecycle and also to inherit from the iTestWare component that we will check it now. So I will create a desktop folder. In this case, the organization is the one that I am using for these workshop purposes, let's say. So inside this desktop, I will create a couple of classes. The first one will be an interface. And I will call this interface eCalculator desktop page. And also I will add a new item, a class called calculator page. Okay. The iCalculator page, I need to inherit from iTestWare component. Okay. Adding the reference and and also I will declare here the methods that I need to make the test case operation. I'm not fulfilling all, just the minimum that I need. So in this case, I will declare a method to resolve the operation. That is what should happen when I press equal. I will create the make add operation. That is what happens when I click on the plus button. Introduce number string number. This is what will happen when I click on the number button and void check operation result. Let's see what is in the LCD in the screen. Expected result. Okay, I had interface, and now I'm moving to the class. This class calculator page inherits from WinAppDriver page that is served from the engine of WinAppDriver, and also is implementing the iCalculator desktop page. Okay, it's complaining because it not had a constructor that sent as a parameter the driver. Perfect. And also it's complaining because it's not implementing the interface. Okay, at this point, we need, first of all, to identify the objects that we will interact with. So let me open again the application and use again the insights. So let's focus, for instance, on this equal button. Set this equal button. Let me stop this. So in this case, we will use, for instance, the name. We could use also the automation ID or any other property. In this case, I will use the name to identify it. So the name is the character equal. So let's go. I will store in this private variable iWeb element equals button with get and set. Okay, I am using an iWeb element instead of iWindows element, for instance, because how is working Appium is translated your application, to a DOM that it's possible to work with all the power of the Selenium, and this is what we are doing here. But we could put a Windows element as well, and will work. Okay, we are using this factory-like using decorators. I think some references are missing, but I will put it later. How we will detect this element? We will find it using this how.name, using with capital this text that we saw with the insights before. Adding some references. We are here on the Appium. This is using with capital. Okay. And for the iWeb element, okay, that's Selenium. So doing that, the class on the construction will detect this, will identify this element and semicolon missing. Will detect this element and will be available when we want to interact with. On the same way, we do the same, but in this case, I will copy paste. We make the same for the plus button for the result text field. In this case, the result text field, you can see we're using the accessibility ID 2010. We use the insights, and I resume this. The accessibility ID, it's the automation ID. Okay. Some translations, fixes that we need to do. I am closing the accessibility insights. We will not use anymore in this workshop. So perfect. So we had the elements. Let's go for the implementation. Check operation result. To check the operation result, we simply you go for this element result text field, check the text, and use here the fluent assertions. In this case, I am using fluent assertion, that is this package that extend these elements to write in this fluent way. Expected result. No. Expected results. Okay, and that's all. In the case of the introduced number, we will receive the number as a string because we need to type the number digit by digit. So let's do that. For each bar digit in number to char array. We can, for instance, look for the element digit. What? Yes, bar digit element equal driver dot. Here we had access to the driver because it's injected by the core and used in the initialization. So we had this driver available to work with. We will find the element mobile by name. In this case, we are looking, we saw before that the numbers in this specific application has the name with the value of the digit. So we are taking advantage of it. Digit dot to string. Okay, a reference missing here. Okay. So once we had the element, we can click the element, digit element, and that's it. We are clicking our number digit by digit. Make operation. In this, for those two last methods, it's the same. Just say that this click element, it's not an Selenium or Appium method, but here in the core we had some layer of robustness that it's getting this click element function, and it's applying retries, looking for the element to be visible, clickable, etc. before interact with, and it's giving robustness on the execution. Addition button, and more or less the same for the resolve operation, but with the equals button. Okay, we had our business object. It was long path until here. Okay. Okay, it's time to connect the dots. So to connect the dots here, the only missing part is the step definition. So what we need to do here, it's first of all, I will be reusing these calculator step definitions, and I will change the intention of this class during the workshop, but just for the purpose of the workshop. We create a new private read only calculator page. It's not, I think it's not an calculator page. Let me check it. iCalculator desktop page. I will add the reference, calculator page. Okay. Reference here. Okay. So I need also a constructor for this class. Calculator step definitions. Okay. And here inside, I need to resolve this calculator page once, just one time. So here I am using the container manager that is provided by the core. Container manager, again, one reference missing. So let me add to take advantage of the autocomplete, it's in the core. Get testware component, and I will ask for a specific testware component, calculator desktop page. Okay. Okay. So right now, this calculator page will be resolved automatically with the specific implementation that we already done since we inherit from iTestWare component. So the business object is registered on the container. Let's go quite fast on the implementation. The first number is when, in this case, we are calling to the interface method introduce numbers and the number. One thing that SpecFlow is doing for you, if you put here an int, it's casting automatically this expression over here to a type int. But in this case, since we want to type digit by digit, for us, it's okay to keep in as a string. Okay, in the case of the second number, when you want to put the second number, first of all, you need to make add operation, and after the semicolon, and after that you could introduce the number again. For us, it's better to not cast to a different type because the natural language is written as a text. For us, no makes sense to make the translation. Okay, the two numbers are added. This means resolve operation. And last, the assertion itself, calculator page dot check results, operation results. And I need to send the result, and I will send as a string also. Okay. Right now we are in position. Let me close the application. We are in position to run the test case. Nice. We had the execution done, and we have our operation on our desktop calculator. And if we check the results folder, we had two folders because actually we did two executions. The one before that didn't work, and this one, and the last one that has the calculator, that is the feature, the add two numbers, that is the scenario. And here we had one screenshot per step that we put it. This is resolved automatically by the code. Okay, intense, 1 hour almost, just to make an addition. Not bad. Okay, what happens when our company release this application, this calculator, in a website? I will, sorry about that. Okay, so we will use this one. The calculator is a bit different from the one that we had on desktop, but has the same behavior, the same operative. The addition could be performed here also. So we will start working to do it, to perform the test, the same test here. For the purposes, so again, for the purposes of this talk, I will duplicate the test case. We are starting here. Okay, these tags are not applying anymore, and I can put on desktop, on web. Okay, let's keep it like this. And yeah, as before, the first step that we need to do is to add the configuration for our new driver. We had one configuration for the WinAppDriver with one specific capability. Right now, I will add a new one. In this case, I will copy and explain. Okay, so the same as before, the WebDriver, it's a tag that it's allowed by our engine. In this case, the name that we are using is calculator web. Here is the path where I am storing the drivers. I want the driver of the Chrome and start maximized. As the same way around, I can add here the WebDriver tag and also the name. Okay. Okay, done. What more we need to do? A part of the configuration. It's not saved. I will close again all, because I had a lot of noise here with all of this. Okay, what more we need to do? We need to go to the Lifecycle, and we need to add the new engine that we want to use. That is new, the new manager, Selenium Manager. Okay. I need to add the reference. Okay. And at this case, it is complaining because it's not able to automatically cast to the type. So I can say, hey, all of this is iEngine managers. Actually, they are. So don't worry about it. Okay, explicit. I am casting explicit. Okay, let's continue with the POM, with the page object model. So I will create the new one for web. I will make a bit of refactor here. I will add a new folder for call, for instance, contracts. And here on this folder contracts, I will create a new interface called iCalculator page. And in this interface, I will put the generic actions. I mean, all the operative that I can do on this on this application and on this application. And I will reserve the specific interfaces of each application for the things that I only could do on one of them. If I had a scientific calculator, for instance. Okay, let me continue with that. I had this iCalculator interface. In this case, the desktop interface. I am moving the contract, the generic contract, to here. And I am making this this interface to implements the generic one. Need this one. Okay. So in the case of the web right now, since I had the same operative, I will create this iCalculator web page, and also I will add a class calculator page. Doesn't matter that it's the same name as the desktop one, because will be resolved and I will find no conflicts on this. Again, for this, I will implement itest where components and iCalculator page references. The references is a thing that you are adding all the time when you are start to creating, but yeah, when you start to growing on, it's not needed anymore. Okay, this comes from web page from our engine, and also implements iCalculator web page. Again, the reference. Okay. Okay. Again, it's complying about a. I make a typo? No. Formatting? No. Sorry, but. Yes. It should come from here. Come on. Demo issues, right? Sorry. The problem here is I want to add a class and I add an interface. My bad. Too fast with the tools. Again, constructor missing. It's not implementing the interface. Okay. In this case, what we are doing to detect the properties, here we have the developer tools, and using the developer tools, we can. Why it's not embedded? Come on. Okay, using the developer tools, we can identify the objects of our calculator, and we had here several properties. For instance, this one, it's type button, has this name divide, this value, so several things that we can use to identify these elements. In this case, the implementation it's quite similar to the previous one, with some differences, but quite similar. So I'm just copying and I'm not re-implementing, otherwise I will be not on time to show you all that I want to show. Okay, some reference missing. Selenium. Selenium. Okay, done. Okay, what's the next that we need to do? For sure, we need an issue here. We need to evolve this step definition. Right now, it's not the interfaces that we are resolving are not okay. Yeah, we had here some things to do. First of all, one thing that SpecFlow allows us, it's to collect. Sorry, it's to collect the context of the execution. So in this case, we can get the feature context and the scenario context. This is because if we put the tags here, we are in a scenario context, and if we put here as we are. Oh, really? Okay, if we put here, we are in the feature context, and we need both. If we put a tag that it's not in the configuration, it's nothing like I put here this one. It's nothing that will be break the thing. We can use tags to link requirements or for whatever we already need. Okay, right now, where I will do is pick the tags of the feature context, feature info, tags, concat, context, scenario, info, tags, dot select, and I will force all of this. I am picking all the tags, and I am forced to put it in lowercase. Just what is complaining here? Reference missing? No. Yeah, it's not the class, but the parameter. So SpecFlow, when you want to receive in the constructor these classes, it is injecting for you, because are in the pool of what work with SpecFlow means, which classes are using SpecFlow. So we had the tags. We will pick also the task for the Appium, WinAppDriver factory. This is a bit, I think I will copy, but we are picking the task that our engines support. So engines, yes. Okay. The one for desktop and the one, semicolon missing here, the one for desktop and the one for web. And right now we will select which kind of calculator page we want based on which tags are executing. Tags dot contains desktop. We are doing like this, and tags contains web. We are doing like this. But in this case, it's not eCalculator desktop, but the interface that we have here, eCalculator web page. We need the reference. And probably we need to say that this is not an eCalculator desktop page, but is an eCalculator page, the generic one. The reference here. Okay. And of course, just to add this layer of reliability, we can throw an exception if we are not resolving to any. Okay, at this point, if I am rebuilding the solution, if I am rebuilding, my expectation, okay, is the second on web, the add to numbers on web appears here, and I think we are able to run it. WebDriver is open, it's navigating, it's making the operation, and it's failing. Oh, come on. Okay, this is my bad. I'm not picking the last implementation. This is something fun, because it's not get attribute, it's get property. Because how it works Selenium when you are looking, no, sorry. Oh yeah. Get property. Where? Okay, it's deprecated. Okay, if it runs for the purpose of this workshop, I will keep okay with that, with this deprecation warning. But it's funny because how, oh. Yeah. The case. Again, it's funny because how Selenium works, it looks for, when you make a get attribute, it's look for the attribute, the HTML attribute of the DOM component, and if found it, retrieves to you this value. But if not, it's looking for the same name in the property in the properties of the attribute. So when I start to preparing this workshop, this element over here doesn't have this attribute value, so it was giving to me directly the property. When I test again yesterday, actually appears this tag value on the application and broke my test case. And I copy paste the old code and happened at this. But okay. Okay, so I will keep this warning. It's a problem for the future me. Okay, we arrived to a point that we had desktop, web. Let's do it. Let's do it for Android also. I will open the Android Studio and I will open. Can close this. And I will open an AVD. At this point, for the time, I'm showing how to identify the elements and so, but it's using the Appium inspector. You connect the session, then you are able to identify in a very similar way that the application Insights is doing. It is possible to use this here. It's possible to use this this Appium inspector to inspect Windows, but my experience is that it's really low. It's loading the whole thing, and it's better in the case of the desktop to use the application insights. But okay, here we had a calculator. If this want to work, no, come on. Okay, as I said, with the stream and all the stuff, I had problems with the RAM. Let's see if it works or not. Okay, I will close the window and I will try to open again from the Android Studio. Okay, in the meanwhile, again, our first manager, our starting point is to add the configuration for our new WebDriver, the new driver that in this case is an Appium driver. So I will copy paste. In this case, the main capabilities here, we are connecting also with the Appium. We had the path to the application to install it. We had the Appium driver and the calculator driver. I will replicate this test case on mobile. This is I am copy pasting to not make typos because I am the boss of the typos. If any typo is possible to do it, is the most probably I am doing it. Okay, so here we had this this part of the mobile. Again, we need to create the POM for the mobile quite fast. Add new interface called calculator mobile. Add new item. The class calculator page. Just for the talk, let me rename it for the talk right now. Let me rename it for the talk right now, just to make the consistency with the rest of the. Okay, iCalculator mobile page. So as the same of the others, this is iCalculator page. And also I test where components. Okay, and for the calculator page, this is a mobile page. I think it is mobile page. Yes. And also implements iCalculator mobile page. As I did in the part of the web, I will copy the part of the mobile. So some references to add. Also the others. and this one. Okay, so we had the implementation of the POM and of the page object model. So we need to add also on the oh sorry, we had to add also on the here the for the tag for the mobile for the Appium. And also here the resolution for Appium. Okay, and in the case of here, we are resolving again I calculator mobile page. One reference to add. Okay. Okay, let me check. Come on. Let me check. Close API. Okay. So I am rebuilding this solution. So we're close to the end on web or mobile here. If I run it, as you can see, each time I'm adding a new source, it's quite fast to do it. Okay. Okay. I forgot it to do it. Want to run a lot. I need to add the new engine that I want to use. New Appium Manager. Okay. Oh. Oh, it says that the application it's not in the place that I put on the configuration. That's weird. That's a bit weird. Let me check it. Let me check it, but it should. Oh, it's true. It's not here. Okay, let me solve. Just a minute. Just a minute. Yeah, this is because I have been cleaning up this thing. It's just a minute, I promise. The path was wrong. Okay. Samples, external resources. Okay. Now it should work. It should work. Please work. Okay. And now I hear like a bell ringing. Looks like at least connected, and it's installing the application because yeah, it's like a new version that I just put it, but it's doing the operative. And we had another pass. Okay. Okay. We are close to the end. close to the end. What I want to do that now, what I want to do now, it's to create a new test case. The same test case. I know I didn't work too much on the test cases, but I want to do the same test case, but add two numbers on the entropy. And this means do it for Appium, do it to the web, and do it to the desktop at the same time. To do that, we will need to make a new refactor here. This class now has a totally different intention that is more related with do the same actions for over multiple drivers or to interact, but just for the purpose of this let's do it just for the purpose of this talk and for fun. So right now I don't want just an object, but enumerable of objects. Okay, and let's say calculator pages. So let's here initialize this calculator pages. While a new calculator page. Let's just initialize. We had the part of the tags that it's okay for us. Now, if contains a desktop, we will calculator pages dot append this thing over here. And I will make the same for the others with one other difference. Not append with, let me finish this first and I continue with the refactor. Come on. Come on. Okay. Okay, now it's not else if anymore. If you detect a good tag, this is not an else anymore. Let's if calculator pages dot any or empty. Let's keep it like this. Okay, and now this we are not able to work like this anymore, but we can do the action for each driver that we had. We will make the same action. Again, just for fun. Let me do it quite fast. Okay. So with this refactor, let me rebuild the solution to appear the new test case. On desktop, on entropy, this one. With this refactor, so it's opening the application, the website. I'm not touching because on the Windows desktop, if you move the browser and so it's not simulating events of any DOM. It needs to make the click over the application that it's in the top of what you are viewing. But this is how it works. As you can see, it's doing the steps on all the platforms at the same time. This probably it has sense in almost in any real scenario, but we found the scenarios that you need that the same test interact with different platforms at the same time, like a web page to check the logs, the audit trails, or to give permissions to something that is happening in a desktop application and yeah, we resolve like this. I want to show you the part of the evidences again. Let's check what happened. We ran a lot of things. If we check this last one, add numbers on the entropy, as you can see here, we had what is happening on each step, on each driver that it's working in. That's more or less that's it. I expect that you enjoy the session and see the powerful how to work with different web drivers, the part of the injection, the reflection, this ability to just implement one interface that allows you to instantiate this business object from any other part of your framework. How we focus mostly today in the business part, how we are testing directly the business part, and we don't need to worry much about the intrinsics, how is working Selenium, how is working Appium, how I can compatibilize both drivers in the same execution. This is provided by this source, this core with the engines and this architecture. I will stop to share now. We'll stop to share. So I don't know if there is any question on the chat, comment, anything that I can comment further. So thank you very much for attending and for your time, and see you on the next session.